Today in this video I'll tell you about how to develop an Android application for BeagleBone which can give PWM output. So let's see the setup. So for this demonstration I'll be using beacon cap. So in this beacon cap we have an LED that is PWM controlled RGB LED, in which red is connected with 42 number pin of P9 header, green is connected with 14th pin of P9 header, and blue is connected with 16 pin of P9 header. If you see this online, then you will find that the 42th pin of P9 header is actually PWM 0. I'll be using this for the demonstration, that is PWM 0. So let me show you the setup. So here is my BeagleBone which has a beacon cap, and this is my display which is showing the Android OS running on BeagleBone Black. Again we will go through the steps of developing an Android application for BeagleBone. So you are familiar with these steps that I described earlier in the previous video. We will be following these steps again. So here I have my PWM project, that is an Android project. So let's copy the GNI folder in this project. So I hope you have downloaded the BBB Android HAL code. So let's copy the code. So we have copied this GNI folder. Now we need to change the android.mk and application.mk file which is provided inside this GNI folder. So we have to simply just copy and paste, replace the old files. Now let's change the GNI wrapper function. Now we have to modify the GNI wrapper.c, in which we have defined our macro, that is java underscore class underscore path. So let's do that. So here we have to modify the path for the class. Let's see what's the path. So here you can see that src, in that you have com.bbb android hal.pwm, then main activity. So we will modify accordingly. Now let's build the code. So you can see that libbbb android hal is generated. Now we have to include this in our source code. So here I have done that. So I have included bbb android hal library. Also we have to define the prototypes of the native functions that we will be using. I have defined that here. So let me briefly explain what these functions will be doing. So here you can see that I have PWM set period, PWM get period, PWM set duty cycle, get duty cycle, set polarity, get polarity, run, stop, and check run. Before that, let us generate PWM using shell script or in the shell. So So here I am in the Android system of BeagleBone Black. Since I'll be using the PWM 0, so I have to export that. So let's export that. So before that we have to do a device tree overlay. We have to overlap that thing. That's why it is giving error, because it is multiplexed, and currently it is in GPI mode, so we have to put that in PWM mode. Then only we will be able to export this as the PWM. So let's do that. So let's do echo, then BB, then bacon, devices, bone manager 9 slots. So we have successfully overlaid this device tree. Let's see if it is successful. So now you can see that we have successfully overlaid this device tree. Now we have set pin number 42 as PWM 0. Now we can easily export that. So let's do that. So now you can see that here PWM 0 is appeared. So let's move in that directory. So here you can find that we have duty cycle in nanoseconds, then we have period nanoseconds, then we have polarity, then we have power run and subsystem event. So amongst these we will be using these four only: duty underscore ns, period underscore ns, polarity, and run. So now just run PWM using shell. So first of all we will set the period, so let's do that. Now let's set the duty cycle. Currently I am using half of the period as duty cycle. Now just run this thing. So I'll be showing you the video output here. So whenever I will press run, then you will see that the LED will glow. You can see that currently LED is not glowing. When I hit enter, so you can see that now LED is glowing. I can change the intensity of the LED by varying this PWM value. So let's keep it full. So you can see that intensity is high. Now let me decrease that. So you can see that intensity is very low now. So this was using the shell. Now we will be developing the Android application for the same. Let's do that. So before doing that, we have to give the permissions to these files so that it can be accessed via the Android application. So let's do that. So chmod 777, then again for period, then again for polarity, then again for run. So now we will be able to use this files in our Android application. So let's do that. So let's first discover the device. Now let's execute this code. So let me explain the code first. So what it's doing. So here is what the graphical output will be like. So we have here poll PWM state, so it will poll the current state and it will display a string here. So it will display the period and duty cycle and the run state. We can provide the period and duty cycle here, and we can set this from the Android application. Then we can run the PWM and stop the PWM. So this will be the functionality of the Android application. So now let's run this application and see the output. So now video, let me show this in the video. So you can see that here that we have output on the screen. You can see that LED is already glowing. So now what I will be doing is I'll just stop the PWM from here. So when I'll click stop PWM, the LED will stop glowing. So let's press this. So you can see that LED has stopped glowing. Again it is glowing. Now let's poll the status of the PWM. So you can see that current period is shown here, duty cycle is shown here, and you can see the run check. We can also provide the period and duty cycle. So let's do that. So I am providing the period currently. So let's provide the full duty cycle. Let's set this value. So I am setting this. So now if we poll the state, then we can see the updated value that both the period and duty cycle are same. And you can see that intensity of the LED is also changed. So this was the output of the Android application. Now again, like previously we set the GPIOs to be exported on the boot time. Now we will be doing the same for this PWM, and we will be also including the automatic inclusion of device tree overlay. So it should be directly overlaid. So let's see that. So I have already created init.generation. So let me show you. So here is the init.generic cam file. So here you can see that we have the sentence for overlaying the device tree overlay for Beacon Cape. Then we have exported the PWM 0. Then we have permissions for all these files. Now I will push this in the Android system. So let's push this. I have to provide the permissions for root to execute this. Now let's reboot. Let's wait for some time. Now the Android has booted. Let's see what had happened. So class. So now you can see that PWM 0 is exported here. Our cape is also overlaid. Let's see that. So you can see that BeagleBone beacon is available here. Now let's see if permissions are proper. So you can see that all the required files have the proper permission. So now we can easily run our application. Let me see that. So let's see if this application will run again. So you can poll the current duty cycle and period. It is 00 and run check is 0. Let's set some period and some duty cycle. Set this value. If you poll that value, then you can see that period and duty cycle has changed. You can see that currently LED is not glowing. Now let's run PWM. So now LED is glowing. Then stop PWM. LED is stopped. So by this I have completed my PWM video. Thank you.